Okay, so to find the nth term of a sequence, we're going to write an expression for the apparent nth term, or a sub n, for each sequence. So the first thing is, notice on A that all of my numbers are positive, so I don't have to worry about alternating positive and negatives like we're going to have to do on B. So I just need to find some expression or some equation here that when I plug in my n value, because remember now this is my first term, this is my second term, my third term, my fourth term, so I'm going to let these be my n's, and these are the actual terms, what we have. Then when I plug in n is 1, I'm going to get 1 as my answer, and when I plug in n is 2, I'll get 3, and when I plug in n is 3, I'll get 5, and n is 4, I'll get 7. So we've got to find some equation that's going to work. Well, one way to do this is you can use a table. Alright, so if you're going to use a table, I'm going to, I'm going to go ahead and write a table as like a T table like we're used to seeing. And so I'm going to skip a little space. I'm going to put my n's over here. I'm going to put my terms over here. So let's see, my n's are 1, 2, 3, 4. And those terms are 1, 3, 5, 7. Well, if you look at this, let's see, to get from 1 to 3, we add 2, 3 to 5, we add 2, and 5 to 7, we add 2. So what this tells me is because it only took one time of finding those differences there, this is going to be linear. And so I know I'm going to have a slope and a y-intercept when it's linear. So remember, for slope, well, first off, if it's linear, I'm looking at y equals mx plus b. So I need to find my slope and my y-intercept to get my equation. So my slope is that change in y over the change in x. So it gives me 2 over 1, which is 2. And then for my y-intercept, well, there's a couple different ways we could do it. But one way to do it is let's just back our table up. Remember, the y-intercept is where you cross the y-axis, where x is 0. So I'm going to back my table up here to 0. And so I went back 1, which means I need to go back 1 here. Well, my constant change is 2, so I need to know what number can I put right there that when I add 2 is going to give me 1. Well, if you're going backwards, that means you're going to subtract 2. And so 1 minus 2 is negative 1. And then just check it. Is negative 1 plus 2 equal to 1? Yes, it is. So it tells me that my y-intercept is negative 1. So my linear line is going to be y equals 2x minus 1. But we're looking for a sub n. Well, that's no big deal. It's just instead of x, we're going to put an n there. So it's going to be 2n minus 1. And then make sure you check it. When you plug in 1, what do you get? Well, 2 times 1 is 2, minus 1 is that 1. Plug in 2, what do you get? 2 times 2 is 4, minus 1 is 3. Plug in 3, 2 times 3 is 6, minus 1 is 5. Plug in 4, 2 times 4 is 8, minus 1 is 7. So it worked on all of them, so this is my equation. Then for B, the biggest thing with B is notice they're alternating. So we have to do something that changes it from positive to negative, but only on my even terms. Because if you look at it, it's not on your first and your third, but it is on your second and your fourth terms. So first thing is that I know my equation, my a sub n is equal to take care of just the negative piece, you're going to do negative 1 raised to some exponent. If you want your odd term numbers to be, your odd n's, if you want them to be negative, then it's just going to be n. But this one, I don't want the odd ones. I want the even ones. I want the second one, the fourth one, the sixth one. So we're going to add 1 to it. So remember, if it's odd, it's just raised to the n. If you want the even ones, then it's n plus 1. Now, we still have a piece of the equation still to do. This piece right there just takes care of the negatives. So now I don't have to worry about them. I don't even put them in my table when I create my table here in just a second. All right, so let's go ahead and create our table. So we're going to put n over here and our actual terms here. So I'm going to skip a little space in case I need to go back to 0. So it's 1, 2, 3, we had 4. And the numbers are 2. Now I'm not going to worry about the negative. I'm just going to look at the 5. I already took care of that negative. 10 and then 17. Now if all of my numbers were negative, then I wouldn't do that at the beginning and I would put the negatives in here. But since they alternate, what we just put right here takes care of it. So I don't have to worry about it in the table. So look to check your differences. Of course, we know our ends are each increasing by 1. It's going to be that way each time because it's my first term, second term, third term, fourth term, etc. But look at your terms. To get from 2 to 5, we add 3. 5 to 10, we add 5. And 10 to 17, we add 7. Because that's not constant, this isn't a linear change. So then check those differences. How do you get from 3 to 5? You add 2. And from 5 to 7, you add 2. These are the same. That's the second time I did it, which means my exponent is going to be a 2. It's going to be quadratic. So I know it's going to have an n squared in it. Now this one isn't too bad. We could actually back this one on up to 0 because if you notice right here on your first differences, it was 7, then 5, then 3. So hopefully you'll notice, well, then this one should be a 1 because we're going down by our odd numbers. So 1, 3, 5, 7, it should work. So what number can I put right there that when I add 1 to it, it's going to give me 2? Well, 2 minus 1, if I work backwards, is 1. And then check it. 1 plus 1 is 2, so it works. So I know that I have, in my equation, I have an n squared, and I have an n plus 1. Now, there could be a number in front of that n squared. We're not real sure. There is that chance. But we're going to use what we've been given to check. So I'm going to take and I'm going to plug when n is 1 into that equation and see if I get 2. If I do, great, check the others. If I don't, then I need to figure out some number I could put in front of that n squared or divide n squared by or do something to this equation that would make it become a 2. So let's try that 1. So when I plug in 1, I get 1 squared, which is 1, plus 1, which is 2. It worked, but you need to check all the others. So plug in the 2. So 2 squared is 4, plus 1 is 5. Remember, we're not worried about the negative. It's taken care of in the first part of the equation. And then plug in 3. 3 squared is 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. So this equation works for all of it. The first part takes care of the alternating negative, and the last part takes care of the digits behind it.